User ID. User ID. In this module we'll have a User ID overview, a User Mapping Methods overview, configuring User ID, PAN-OS Integrated Agent configuration, Windows-based agent configuration, configuring group mapping, User ID and security policy. For more information about the packet handling sequence inside of a PAN-OS device, refer to the Packet Flow Sequence in PAN-OS document, available on the Palo Alto Networks support website at live.paloaltonetworks.com/docs/doc1628. User ID overview. The increasingly dynamic nature of users and applications means that IP addresses alone have become less effective as a mechanism for monitoring and controlling user activity. User ID technology identifies the user on the network and the IP addresses of the computers the user is logged into. User ID also retrieves user group information from a connected LDAP directory. The ultimate purpose of User ID is to provide you with the ability to write policy and view logs and reports using user names instead of using just IP addresses and port numbers. User ID combined with App ID technology provides you with very granular control over which users or user groups may access which applications from which network segments. For example, unknown users can be treated differently from known users to accommodate network guests. Multiple policy types support User ID. You can use user or group names as match criteria in security, QoS, policy-based forwarding, decryption, tunnel inspection, authentication, and DOS protection policies. Before you can create user and group-based policy rules, the firewall requires a list of all available users and their corresponding group mappings. The firewall uses group mapping and user mapping to collect this information. The firewall collects group mapping information by reading group information directly from your LDAP directory server. User ID technology includes many methods to collect IP address to user mapping information. You can choose which user mapping methods to use to suit your environment, and even use different methods at different sites. User ID technology has four main components. The table lists each component's name and primary characteristics. The User ID agent comes in two forms, an integrated agent resident on the firewall or a Windows-based agent. The PAN-OS integrated agent is included with PAN-OS software. The Windows-based agent is available for download from Palo Alto Networks and can be installed on one or more Windows systems. A firewall can communicate with both agent types at the same time. Both agent types monitor up to 100 domain controllers or exchange servers. Both agent types can monitor users and domain controllers only from a single Active Directory or AD domain. The integrated agent is designed for small and mid-sized deployments, such as small remote offices or lab environments. Multiple Windows-based agents can be deployed to handle larger environments or multi-forest domains. Although both the Windows-based agent and the PAN-OS integrated agent perform the same basic tasks, they use different underlying communication protocols. This difference makes each one more appropriate for different environments. The Windows-based agent uses MSRPC, which requires the full Windows security logs to be sent to the agent, where they are filtered for the relevant user ID information. The PAN-OS integrated agent uses Windows Management Instrumentation, or WMI, which enables the agent to retrieve only the relevant user ID information from the Windows security logs. The result is that in an infrastructure with remote networks separated by WAN links, the integrated agent is more appropriate for reading remote logs, and the Windows-based agent is more appropriate for reading local logs. However, use of the integrated agent is not without cost. It consumes more of the firewall's management plane resources. And for this reason, deployment of the Windows agent at remote sites and having them forward the relevant user ID information to a firewall on a central network often is beneficial. User Mapping Methods Overview. User ID technology includes multiple methods to map IP address to users. The decision about which methods you employ depends on the operating systems, applications, and network infrastructure used in your organization. If any of the methods successfully maps an IP address to a user, the user's name can be used by the firewall for policy rule matches, logs, and reports. The following list is a brief description of each method shown in the illustration. User ID monitors Microsoft Active Directory domain controllers, Microsoft Exchange servers, or Novell eDirectory servers for login or logout events recorded in authentication logs. User ID also reads session tables to confirm known IP address to user mappings based on current Windows file and printer shares. User ID probes Windows systems to verify current user mappings and to discover new IP address to user mappings. User ID acquires username information from captive portal web forms and login events on Global Protect client machines. User ID maps IP address and port number combinations to usernames for Microsoft Remote Desktop Services and Citrix Presentation Server, or Citrix XenApp. User ID listens for syslog login and logout messages from Network Access Control, or NAC, systems, 802.1x devices, and wireless controllers. When other methods cannot be used, User ID can consume PAN-OS XML API user login and logout messages sent from terminal servers, NAC systems, and other network devices that can format and send XML over HTTP. The diagram and text provide an overview of the operation of User ID technology in the scenario where User A logs into their laptop. The laptop is an Active Directory domain member, so User A's logon information is recorded on the Active Directory domain controller. The logon information includes User A's username and IP address. Before User ID can operate, it must be enabled on the security zone. If User ID is enabled, then the firewall consults the administrator-defined User ID configuration to determine which agents the firewall has available to gather IP address and username information. Depending on the configuration, User ID on the firewall could query either an integrated agent or a Windows-based agent. The agent retrieves IP address and username information from the domain controller. After user ID has retrieved the IP address and username information from an agent, it can use the firewall's LDAP configuration to retrieve the user-to-group mapping information from an LDAP server. At this point, user ID will have an IP address associated with a username and possibly a username associated with one or more group names. If traffic arrives from the IP address associated with user A, the firewall can use the user ID information to check its security policy rules for a match and determine how to handle traffic from user A. With passive server monitoring, a user ID agent, either a Windows-based agent or the integrated user ID agent, monitors the security logs for user logon or logout events for the specified Microsoft domain controllers. When the user ID agent first starts up, it will parse the security event logs and record all of the user logon events. Afterward, it will check the security logs on a regular basis for only new logon or logout events. And user mappings are cached for an amount of time equal to the timeout value set in the user ID agent interface. Note that for security events to be recorded in the security logs, the AD domain must be configured to log successful account logon events. Because users can authenticate to any domain controller in a domain, and the security logs are not replicated between domain controllers, you also must set up server monitoring for all domain controllers to capture all user logon events. Each user ID agent can monitor multiple domain controllers per domain. However, each user ID agent can monitor only a single domain. Because server monitoring requires very little overhead, and because the majority of users generally can be mapped using this method, Palo Alto Networks recommends it as the base user mapping method for most user ID deployments. Clients who have connected to a shared file or print resource will have their session information stored on the domain controller. An additional Windows-based method to resolve IP addresses to users is to consult the shared resource session table recorded on the domain controller. Server monitoring on the domain controllers provides one reliable method of mapping an IP address to a user, but it cannot address environments where the user might switch IP addresses without logging back into the domain. One scenario where this situation might occur is with laptops and wireless networks. A laptop user could log in from one IP address, such as a wired interface at their desk, and then later in the day roam to another IP address on a wireless network. In a Microsoft Windows environment, you can configure the user ID agent to actively probe client systems using Windows Management Instrumentation, or WMI. The Windows-based user ID agent also can perform NetBIOS probing, but WMI is preferred because of better authentication and better reliability. Probing is particularly useful in environments with a high IP address turnover because IP address to user mapping changes will be reflected on the firewall more quickly, thus enabling more accurate enforcement of user-based policy rules. However, if the correlation between IP addresses and users is fairly static, you probably do not need to enable client probing, because probing can generate a large amount of network traffic based on the total number of mapped IP addresses. The agent that will be initiating the probes should be located, if possible, at the same network site as the end clients. If probing is enabled, the agent periodically will probe each learned IP address, every 20 minutes by default, to verify that the same user is still logged in. The list of known IP addresses is cycled through once each period. When the firewall encounters an IP address for which it has no user mapping, it sends the address to the agent for an immediate probe. For mobile or roaming users, the Global Protect client provides the user mapping information to the firewall directly. In this case, every Global Protect user has an agent or app running on the client that requires the user to enter login credentials for VPN access to the firewall. This login information then is added to the user ID user mapping table on the firewall for visibility and user-based policy rule enforcement. User ID information can also be provided from clients that are connected to an internal network via an internal Global Protect gateway without establishing a VPN tunnel to a firewall. Every internal Global Protect user has an agent or app running on the internal client that requires the user to enter login credentials that can be used by the firewall. Because Global Protect users must authenticate to gain access to the network, the IP address-to-user mapping is explicitly known. Global Protect is the best solution in sensitive environments where you must be certain of who a user is in order to allow access to an application or service. For more information about setting up Global Protect, see the Global Protect Administrator's Guide at paloaltonetworks.com/documentation. The table shows the circumstances under which different user ID components and mapping methods are recommended by Palo Alto Networks. Configuring user ID. The list shows the 4 general steps to configure user ID technology. The specific steps to configure group mapping, and particularly user mapping, depend on your environment. Definition of policy rules based on group names rather than on individual user names simplifies firewall administration because you do not have to update the rules or perform a commit where users are added to or removed from a group. Enable user ID technology per zone on the firewall. For each zone, you must click the Enable User Identification checkbox to activate User ID on the zone. User ID tracks only users associated with the source zone of a session. Never enable User ID for a zone that contains the Internet, or your firewall will attempt to identify every user from outside your network. By default, User ID will try to map users from all subnetworks found within a User ID-enabled zone. Use the Include list to limit the subnetworks or specific addresses that the firewall will attempt to map to users. Use the Exclude list only to exclude user mapping information for a subset of the subnetworks you added to the Include list. If WMI probing is enabled, WMI will not probe public IP addresses by default. Public addresses are those not found in the IP addresses, ranges 10.0.0.0 to 10.255.255.255, 172.16.0.0 to 172.31.255.255, and 192.168.0.0 to 192.168.255.255. To enable WMI probing to map public addresses, you must use the addresses or the address ranges in the Include list. PAN-OS Integrated Agent Configuration. User ID technology provides a variety of mechanisms to reliably identify network users and their associated login session information. Some mechanisms require the use of a user ID agent to provide the most transparent user experience. The list shows the main steps used to configure a PAN-OS integrated agent to connect to monitored servers. Each user ID agent must be configured for the servers it needs to monitor. The agent includes an auto-discovery feature that automatically identifies available Microsoft Windows servers via DNS for event log monitoring. The firewall will discover domain controllers based on the domain name entered in the Domain field of the Device, Setup, Management tab, General Settings page. Set the domain credentials for the account the firewall will use to access Windows resources. This setting is required for monitoring domain controllers and Exchange servers and for optional WMI probing. The information in the username field must be entered using the domain name username. No special permissions configuration is necessary if the integrated agent runs as an account that belongs to the domain administrators group or belongs to the server operators and event log readers groups. However, membership in these groups provides the account with more permissions than just the capability to perform server monitoring or client probing. Therefore, you might want to run the agent using a restricted account with minimal permissions. To create a Windows account with minimal permissions, refer to Permissions Configuration Instructions in the PAN-OS Administrator's Guide at paloaltonetworks.com/documentation. The steps to configure an account with minimal Windows permissions depend on which version of the Windows operating system you have. To enable session monitoring, click the Enable Session checkbox. This setting enables the integrated agent to use current file and print sharing information to verify current IP address-to-user mappings. You can enable the integrated agent to perform WMI probing for each client system that the user mapping process identifies. The integrated agent periodically probes each learned IP address to verify that the same user is still logged in. When a firewall encounters an IP address for which it has no user mapping, it sends the address to the integrated agent for an immediate probe. WMI probing by default does not probe public IP addresses. To probe public IP addresses, you must add these addresses to the agent's include list. See the page in this module titled Enabling User ID per Zone for more information about include list and exclude list. You also must enable file and print sharing on each client. After you commit your configuration changes, the status of each of your monitored servers should display as connected. Windows-based agent configuration. The list shows the main steps used to configure a Windows-based agent to connect to monitored servers. The Windows-based agent can be installed on 32 or 64-bit machines running Windows XP, SP3, or later. You should install the agent in the same network site as the monitored server in order to optimize bandwidth use. You should install 2 agents on 2 member servers for redundancy in case one agent or one domain controller fails. Note, although an agent could be installed directly on a domain controller, it is not best practice. Use your Palo Alto Networks support account to log in to the support website. Once logged in, click the Software Updates link to open the page illustrated here. To simplify finding the user ID agent download links, use the Filter By menu to filter the list for User Identification Agent. Then find and download the User ID agent version that matches your PAN-OS system. Also, download the Release Notes document because it contains important information about supported hardware configurations and software versions. There are 2 choices for installing the agent software. You can install each agent individually by manually launching the downloaded MSI file. Beginning with PAN-OS version 8.0, you can use endpoint management software, such as Microsoft System Center Configuration Manager, or SCCM, to remotely install, configure, or upgrade multiple agents in a single operation. Open the User ID Agent window after the agent software has been installed. Click Setup in the left side pane to configure the User ID agent. Click the Edit button to open a separate tabbed window that enables you to change any of the settings shown in the Setup pane. Click Save to save your configuration changes but not to activate them. Click Commit to save and activate your configuration changes. Click Exit to close the window without saving your changes. By default, the User ID agent uses TCP port 5007 to communicate to the firewall. You can change to another port if necessary by clicking Edit and then clicking the Agent Service tab in the window that opens. The agent should run with a Windows Service account that has the necessary permissions to read the security event logs or to perform WMI probing. Use the Authentication tab to configure the agent to use a specific Windows Service account. The authentication information must be configured before you can configure access to monitored servers. By default, the Windows agent runs as the user account used to install the .msi file. Most of the necessary permissions are provided if the Windows-based agent runs as an account that belongs to the administrators group for the domain or belongs to the server operators and event log readers groups. The user account running the agent must also have permissions to start a Windows service. However, membership in these groups provides the account with more permissions than just the capability to perform server monitoring or client probing. Therefore, you might want to run the agent using a restricted account with minimal permissions. To create a Windows account with minimal permissions, refer to Permissions Configuration Instructions in the PAN-OS Administrator's Guide at paloaltonetworks.com/documentation. The steps to configure an account with minimal Windows permissions depend on which version of the Windows operating system you have. Use the Server Monitor tab to configure server monitoring or to enable the optional session monitoring. Use the Client Probing tab to configure the agent to probe IP addresses for username information. Unlike server monitoring, probing is an active method. The Server ID agent sends a probe at a configurable interval to each learned IP address in its list to verify that the same user is still logged in. The results of the probes are used to update the records on the agent, which are passed on to the firewall. Each learned IP is probed once per interval period. WMI probing must be enabled on the Windows machines for the probe to be successful. Ensure that large environments have a long enough interval for all IP addresses to be probed. For example, a network with 6,000 users and an interval of 10 minutes would require 10 WMI requests a second from each agent. These probes are queued and processed by the agent as needed. If you enable the optional NetBIOS client probing feature, then the agent requires access through the Windows firewall to port 139. Windows file and print services also must be enabled. NetBIOS probing is primarily available for backward compatibility with Windows XP and earlier and is not recommended. Select Discovery in the left side pane to configure the monitored servers and networks. The Auto Discover button works only for domain controllers. Use the Add button to add Exchange servers, Novell eDirectory servers, and syslog senders, or to manually add domain controllers. Click Add to open a separate window where you are prompted for a server name, server address, and server type. The firewall must be configured with information for every user ID agent that it will connect to. If the firewall will connect to a Panorama server to collect user ID information, then select Serial Number as the host type. If the firewall will connect to a window-based agent or to an agent on another firewall, then select Host Port as the host type. If you select host port, then each agent's IP address and listening port must be specified. Communication between the firewall and a user ID agent is secured using an encrypted SSL connection. The firewall has the following specific, non-configurable timers for its communication to the agent. 2 seconds. Get the list of new IP address to user mappings from the agent. This list contains only new mappings since the last interval. 2 seconds. Send the list of unknown IP addresses that were encountered in traffic to the agent. 5 seconds. Get the agent status. 1 hour. Get the full list of IP address to user mappings from the agent. Use the firewall's web UI and the Windows agent to confirm connectivity between the firewall and the Windows agent. Use the Monitoring tab in the Windows agent to display IP address to usernames mapped by the Windows agent. You can display how users and IP addresses are being mapped on the firewall only by using the firewall CLI. Commonly used commands for checking user ID mappings include the following: Show user ID agent statistics, show user IDs, show user IP user mapping all, show user IP user mapping IP/netmask, configuring group. You can display how users and IP addresses are being mapped on the firewall only by using the firewall CLI. Commonly used commands for checking user ID mappings include the following: show user ID agent statistics, show user IDs, show user IP user mapping all, show user IP user mapping IP/netmask, configuring group mapping. A server profile specifies which LDAP servers will be contacted, the order in which they are contacted, and how and where to search the LDAP directory tree. By default, port 389 communicates to the LDAP server using TLS. To use SSL instead, specify port 636. The Type menu specifies the type of LDAP server to which the firewall will connect. The base DN field represents the point in the LDAP directory tree that the firewall will begin its search for users and groups. The base DN information should auto-populate from the LDAP server when you click the base DN drop-down arrow, but you can manually override the value. If you have difficulties identifying your directory-based DN, on the domain controller open the Active Directory Domains and Trusts Microsoft Management Console Snap-in and look at the name of the top-level domain. The bind DN and password fields contain the LDAP username and password that the firewall uses to connect to the LDAP server. The format of this field must match what the LDAP server is expecting. For examples, it could be either a fully qualified LDAP name, for instance, CN equals users, DC equals CSE, DC equals local, or a user principal name, such as administrator at cse.local. The bind DN account must have sufficient LDAP permissions to read the LDAP directory. If universal groups are used in AD, the Global Catalog, or GC server, must be used to capture group memberships. For the firewall to access a GC server, the LDAP port must be set to 3268 rather than to the traditional LDAP port of 389 or 636. The default timeout and interval settings can be overridden as necessary based on the performance of your network and LDAP server. Ensure that the Require SSL TLS Secured Connection checkbox is selected. By default, it should be. To have the firewall verify the LDAP server certificate, select the Verify Server Certificate for SSL Sessions checkbox. On the Server Profile tab, use the Server Profile menu to select your LDAP server profile. The domain setting value normally is blank. Enter a NetBIOS domain name value only if you need to override the domain automatically detected on the LDAP server. The Group Objects fields are dynamically populated. Modify the Group Objects fields to configure the firewall to look for group names and non-standard LDAP tree locations. The groups found by the firewall will be displayed in the Available Groups pane on the Group Include List tab. The User Objects fields are dynamically populated. Modify the User Objects fields to configure the firewall to look for user names in non-standard LDAP tree locations. To match user ID information with email header information identified in the links and attachments of emails forwarded to Wildfire, enter the comma-separated list of email domains in your organization in the Mail Domains section. When a username match occurs, the username in the Wildfire Log email header section will contain a link that opens the WebUI's ACC tab, filtered by the username or group name. The Group Include List tab is used to filter which groups discovered on the LDAP server are displayed on the drop-down lists in Firewall Policy Rules. By default, if you do not move groups to the Included Groups pane, all discovered groups are available in Policy Rules. The Custom Group tab enables you to define custom groups based on LDAP filters, so that you can base firewall policy rules on user attributes that do not match existing LDAP user groups. Definition of custom groups can be quicker than creation of new groups or by the change of existing groups on an LDAP server, and does not require an LDAP administrator to intervene. User ID maps all the LDAP directory users who match your filter to the custom group. For For example, you might want a security policy rule that allows only users in the marketing department to access social networking sites. If no LDAP group exists for that department, you can configure an LDAP filter that matches users for whom the LDAP attribute department is set to marketing. Log queries and reports that are based on user groups include custom groups. You can add custom groups to the Allow list of authentication profiles. User ID and security policy. When you select users for a security policy, these options are available. Any matches any value for user. Pre-logon, used with certain Global Protect implementations. Known user, matches any user or group identified by user ID. Unknown, matches traffic where the user could not be identified by user ID methods. Select, matches a specific user or group identified by user ID. When you use a user or group in a policy rule, remember that the source address field and the source user field are evaluated with a logical AND condition. The rule applies only if both the specified user or group and the specified source addresses match. Be careful not to make the match conditions so specific that the policy eliminates permitted traffic. Users and groups can be used in a policy rule only if they are known on the firewall. For larger environments, a best practice usually is to set policies based on groups rather than on individual users. The number of users often becomes unwieldy for defining policy as the number of users in an environment increases.